the degree of the carbon to which alcohol is connected. Like if I'm gonna ask you, what is the degree of this alcohol? You just need to calculate the degree of carbon of this. You just need to calculate the degree of carbon of this to which OH is connected, and you know this is 1 degree. That's why it is 1 degree alcohol. In the same way, if you want to see the 2 degree alcohol, this is your 2 degree alcohol. And if you want to see the 3 degree alcohol, this will be your 3 degree alcohol. So this is the second classification of alcohol. Then we are going for third classification, and that is, I'm going to change the slide, and that is basically your vinylic alcohol. And here comes the vinylic alcohols. Wait a minute. There are two types of alcohol. One is vinylic and another is allylic alcohol. So first I'm going to talk about allylic alcohols. Allylic alcohol is the one you can see CH2 double bond CH, and then comes your CH2S. That means basically to the carbon OH is connected should be sp3, and adjacent carbon to this carbon sp3 carbon should be doubly bonded. So this is allylic alcohols. And if you are going for vinylic alcohols, and wait a minute, for allylic alcohol we have another term, that is benzylic alcohol. Only the difference is that only the difference is there will be a benzene, and you know this will be CH2OH. You can see to the carbon OH is connected, this is sp3, and adjacent carbon is doubly bonded. So this is your benzylic alcohols. And then comes your vinylic alcohol. That means OH is connected to the doubly bonded carbon. That is your vinylic alcohols. You can see this is your benzene and OH is directly connected. This is known as your phenol. Is that clear? Or we call it aryl alcohol, but generally it is known as phenols. Is that clear? This classification is very easy and important. This allylic and vinylic. Vinylic means to the carbon that is connected, to the carbon which is connected should be sp2, and allylic means to the carbon which is connected should be sp3, and this adjacent carbon should be sp2. Can I change the slide? Just let me know.
Yes, sir.
Yes, sir.
Okay. Now we are going for the next preparation. Basically, the next topic, that is methods of preparation of alcohols. Methods of preparation of alcohols, and this is the first topic, that is from alkenes. From alkenes, and in this we have another subtopic, that is by acid catalyzed hydration. That means you are going to react this with water in the presence of acid. Now you are going to see the reaction. It's very easy. Let me show you the reaction. So by acid catalyzed hydration, if you are going to react this, alkene, wait a minute, if you are going to react this alkene with water in the presence of acid, you know what will happen? Do you know this H2O will be divided into two parts, that is H plus and OH minus, and this reaction follows Markovnikov. This reaction follows Markovnikov, and in the previous chapter, I already have told you that what is Markovnikov. Markovnikov is the one in which negative part will go to that doubly bonded carbon, which will have lesser number of hydrogen, and positive part will go to that carbon, which will have greater number of hydrogen. But here symmetrical alkene is there, so anyone can go anywhere, and it will be like this. This bond will be broken in this way. This will take place. Are you getting my point? Since this is an alkene which is symmetrical, so whether you are going to put this H plus on the left carbon or right carbon, it won't affect. Are you getting my point? This Markovnikov or anti-Markovnikov is for asymmetrical. So I'm gonna give you another example of this. You just need to break the bond and add H plus and OH minus to the respective carbon. If it is if it is a symmetrical alkene, you can add at any place, it won't affect. But if it is asymmetrical alkene, then you are going to add negative part to that carbon which is having lesser number of hydrogen. Everyone getting my point?
Yes, sir.
Okay. Now I'm going to give you this question. Please do let me know. Please do let me know the answer. H2 in the presence of H. Wait a minute, please. MJ, instead of writing the formula of the compound, you should write the name of the compound. It will revise your IUPAC as well. Nah, that's a good answer, correct answer. So see what you are going to do, break this bond and H2O will be divided into two parts, H plus and OH minus. This negative part will go to that carbon which will have lesser number of hydrogen. So this will be the product that you will get, and positive part will go to that carbon which will have greater number of hydrogen. So this will be the product. Always remember that this reaction proceed through formation of carbocation. Formation of carbocation. This is very important. The intermediate here will be carbocation, and whenever in any reaction the intermediate is carbocation, then rearrange it if possible. Then rearrangement will take place if possible. Rearrangement will take place. Will take place if possible. If possible. I will show you the mechanism and you will understand it. See how the mechanism will work here. I'm gonna show you. See, this is your CH3. As you can see, this is your CH3 CH double bond. So this will, you know that which part will basically either this can go on the middle carbon and either this can go on the terminal carbon of the right hand side. So if it will go on the middle, it will be negative here and then positive here. And if it will go on the terminal of the right, you can see positive will be in middle and negative will be on terminal. So as you can see, 2-degree carbocation is more stable as compared to 1-degree carbocation. That's why this is more stable, and OH will come and combine with this and you will get this product. Is that clear? So in the same way, whenever questions like this will come, you are going to form a carbocation. So I'm going to form a carbocation like this. You can see like this. And since this carbocation will be more stable than the carbocation formation here, because it is 2-degree carbocation, and then you can see if you want to move this to right hand side, it will become 1 degree, but if you will move on the left hand side, it will become 3 degree. So I'm gonna do 1 comma 2 hydride shift, H minus shift. So if you are going to do hydride shift, that means the hydrogen from this place will move to this carbon and positive charge from this place to this place. So as you can see, this will happen and positive charge is here. Now 3 degrees more stable than 2 degree. That's why this will take place. And as you can see, now OH minus will come and attack on this place. And this is how you will get 1 2 3 4 5, right? Oh, wait a minute, wait a minute, wait a minute. Yeah, OH minus will be attacking here and it will be like this. So 1 2 3 4 5. So the answer is 3 methyl pent pentane 3-ol. Pentane 2-ol or 3-ol? MJ, KV, Krishna? 3-ol. Marita, if you still have any doubt in this, please do let me know. Everyone, I'm asking from everyone. I will take another example to explain.
Sir.
Ashrit?
No, sir.
Okay. Rehan?
No, sir.
Okay. So can you change the slide?
Yes, sir.
Okay, so let me give you a question before, since everyone just crossed class 12, you all have given the class 12 exams. So the concept is basically clear, right? You know, if you have any specifically doubt in any topic, just let me know. I'm gonna give you some question, not some question. I'm gonna give you a question. Please do let me know. I'm gonna give you option like the main product is very good, MJ. Is there any answer, any other answer? Ashrit, Krishna, Rehan, Priya, Adriel? Good, Adriel. I'm waiting for the answer. No, Krishna. Priya, no, it's wrong. You just need to rearrange it. It's very important. Krishna, how can it be D? Rehan, good. Ashrit, any answer from you?
Send, sir.
You sent me?
Oh, I sent the other chat. Okay.
Please do send it. Oh no, it's wrong. See, I'm gonna explain it. First, there is two possibility. See, either there is a carbon here and carbon here. Either this carbon will gain in the electron, so there will be positive here. There will be positive here. Hydrogen will come and go there, and it will be like this. Or if it will be like this. Then you can see the possibility is this. So as you can see, 2-degree carbocation is more stable than 1-degree carbocation. So this is not possible. This is now whenever carbocation formation takes place, then there will be rearrangement if possible. As you can see, there is positive charge, and if this charge moves to this will be 1 degree, which is not possible. But if this will be here, positive charge, it will be 3 degree, and it is possible. So what you need to do, just write the positive charge here. Basically, what happens here? Hydrogen is here. You just need to shift this hydrogen to this side, and positive charge will be here. Now it is more stable. It will be more stable 3 degree. Then what happens? Hydrogen will come and then attack on this position, and from OH minus you will be getting OH minus from base. And in this way, you will be getting in this. So the answer is B. Is that clear, everyone? Can I change the slide? Ashrit, Krishna, and
Yes,
Priya.
sir.
Yes, sir.
Who be focused here? Okay. Now see, if we are going to prepare this, the second method is by hydroboration. By hydroboration. It's very simple. Hydroboration oxidation. Everyone should take care of Markovnikov and anti-Markovnikov. As you know that this hydroboration is anti-Markovnikov, and now it will be very easy. Anti-Markovnikov. And see here, if you have an alkene, Markovnikov, what does anti-Markovnikov says, and how you are going to basically the alkene is treated with BH3 or B2H6, we can write. First, you are going to treat this with BH3 or B2H6 and tetrahydrofuran. And in the second step, you are going to treat this with hydrogen peroxide in the presence of base. So there will be generation of two things, H plus and OH minus. And you know that in anti-Markovnikov, with the help of this, you will be getting H plus and OH minus. From BH3, you will be getting H plus, and from OH minus, you will be getting OH minus from base. And anti-Markovnikov, negative part will go to that carbon which will have lesser number of greater number of hydrogen, and positive part will go to that carbon which has lesser number of hydrogen. So it's very simple, isn't it simple? With the help of this, by this method, hydroboration oxidation, we will get only primary alcohol. We will get only primary alcohol, and it follows anti-Markovnikov. So, what will be the name of the product? Tetrahydrofuran, and this is your H2O2 in the presence of OH minus. The product is simple. It will be pentanol. Yes or no?
Yes, sir.
Can I change the slide?
Yes, sir.
No. See, the next preparation is from carbonyl compounds. From carbonyl compounds. And in this, we have the first one, that is by reduction of aldehydes and ketones by reduction of aldehydes and ketones. If you remember in class 12, you have studied that if you are going to oxidize primary alcohol or 1 degree alcohol, it will be oxidized to aldehyde. And if you are again going to oxidize an aldehyde, it will be oxidized to carboxylic acid. And if you are going to oxidize secondary alcohol, it will be oxidized to ketone and vice versa. That means if you are having an aldehyde and you are using a reducing agent, then from aldehyde you will be getting 1 degree alcohol. And if you are going to reduce ketone, you will be getting 2 degree alcohol. So I'm gonna show you the reaction. First, the general reaction, RC double bond OH. And if you are going to use either NaBH4, sodium boron hydride, or LiAlH4. LiAlH4 is a very strong reducing agent, or either we can use H2 in the presence of nickel. So how it will be reduced? It's very simple. One bond between carbon and oxygen will be broken. Hydrogen will be added here. Hydrogen will be added here. So you can see RCH2OH will be formed. So 1 degree from aldehyde, 1 degree. But if you are using, if you are having an ketone and you are using these reagents, then you can see you will be getting hydrogen here and hydrogen here, and in this way you will be getting 2 degree alcohol. So when you are going to reduce aldehyde with the help of a reducing agent, mild reducing agent or a strong reducing agent, you will be getting 1 degree alcohol. But when you are going to reduce ketone, you will be getting 2 degree alcohol. Is that clear? So it's simple. Aldehyde, from aldehyde, 1 degree alcohol. And from ketone, 2 degree alcohol. Is that clear? Can I change the slide?
Yes, sir.
Okay. Okay. Now see. By reduction of carboxylic acid, by reduction of carboxylic acid or ester and ester, if we are going to reduce carboxylic acid and ester, you will get alcohol. But with what reagent? Which reagent we should apply on this? See this, if you are going to apply NaBH4, NaBH4 on either carboxylic acid or on either ester, this NaBH4, which is sodium boron hydride, will not reduce. Why it will not reduce? I'm gonna write it here. It will not reduce because it only reduces aldehyde and ketone. It cannot reduce. It is not that much powerful reducing agent to reduce carboxylic acid and ester. So we are going to use lithium aluminum hydride, lithium aluminum hydride, and then this will be easily reduced. So what will happen here? It's very simple. You are going to add hydrogen here, hydrogen here. You can see this will be your R dash OH, R dash OH plus. Now you are going to reduce bond break here and here. You will be seeing RCH2OH, RCH2OH. And in the same way, if you are going to break this, you can see hydrogen here, hydrogen here, hydrogen here, hydrogen here. So you can see RCH2OH, 1 degree alcohol, and you can also see this H2O is the bipole. So it's very, very simple. Let me know when to change the slide. Krishna, Ashit.
Done, sir.
Yes, sir.
Now I'm going to give you a question and then do let me know. What is the product? These are options. Oh, wait a minute. Wait a minute. Option A, B, C, and D is none of this. Option B, MJ. Adriel, very good, very good. Adriel and Krishna, any answer from you?
Sir, I have sent you.
No, very good, PD. Very good. Ashrit,
Yes, sir.
what, what is the answer? See, it's very simple. NaBH4 is a mild reducing agent. So this is your what? This is your ester, and NaBH4 cannot reduce itself, so it will be as it is. But it can easily reduce this aldehyde. So it will reduce aldehyde. Sorry, this ketone, and the ketone will be reduced to alcohol. So the answer will be B. Can you change the slide?
Yes.
Thank
Yes,
you.
sir.
Now the next is from Grignard reagent. Grignard reagent. So see, what is Grignard reagent? Grignard reagent, you already know that RMGX. So I'm gonna give you some questions since you have already studied about this. So you can easily do this. R dash MGX is here. So first of all, you are going to react it with RMGX and then followed by water. So first you need to do this reaction. So see, I'm gonna explain the first reaction and then you are going to do the rest. You know, carbon, oxygen. Oxygen is more electronegative element, so it will have negative and there will be positive. Now this R will have negative because it is more electronegative than Mg, so it will have positive. So this will be attacking here. So I'm gonna write it like this: CH2, because this carbon has two hydrogen, and this carbon is attacked by this R dash, which is bonded with now singly bond O negative Mg positive X. And after this, you are going to do the hydrolysis. You know, hydrolysis, water has two parts, H plus and OH minus. And you can see this H plus will be directly going here, and you will be getting R dash CH2 with O. Hydrogen will go, and this OH minus will be going with this magnesium, and it will be MgOH. So basically, this is your formaldehyde, or we can call methanol. If you are going to react methanol with Grignard reagent, we will be getting 1 degree alcohol or primary alcohol. So this is the mechanism how you are going to react this. This carbonyl compound C double bond O, oxygen will take electron from carbon. So the alkyl part from the Grignard will be attacking on that carbocation formation. This is not basically carbocation formation. It is basically there will be deficiency of electron and they will combine. After that, you are going to do the hydrolysis and you will get your answer. So you are going to write the main product, that means final product after hydrolysis for this, and also for this. And please do let me know the degree of the alcohol that you have. Today we will talk about our syllabus, because now we have some chapters that is completely from class 12, and I consider this and I hope that your basic part of the class 12th is complete. That means that concepts are clear. So we will be focusing on the PYQs of JEE mains and very good questions on that. So instead of covering this part, which is I think you already know, we will do some good questions. Adriel, very good, very good. Very good. MJ, please do write the degree. Very good. Very good, PD.
Sir, should we write the degree only?
Yeah, degree. Directly you are going to write the degree. See what will happen. This will go like this. So there is CH3. So I'm going to write it like this. CH3 is there, CO negative. And you can see H is there. And this will be attacking here. So this will be your R dash, and Mg plus will come here, Mg plus X. So after hydrolysis, you know that H plus and OH minus, this H plus will be going with directly oxygen, and you will be getting CH3CH, OH is there, and R dash is there. So 2 degree. And if you are going to complete about this, so there will be negative. This will be attacking here. So what we will get, CH3CO negative, and then Mg plus X will come here, and then CH3, and this R dash will come here, and then after hydrolysis, you know that this will come here. So CH3COH will be this, and this will be like this. So tertiary, right? Very good. Very good, PD, MJ, master, second degree and third degree. Okay. So this is how we do prepare from what? From Grignard reagent. Now I'm gonna give you some question. Before giving some question, I'm gonna write this topic: physical properties. Physical properties. And in physical properties, I'm going to talk about boiling point first. Always remember that this boiling point is directly proportional to molecular weight. If I'm going to ask you, this is your methanol, this is your ethanol, and this is your butanol, which one will have the highest boiling point? You need to write the boiling point order. So butanol will have the highest, then ethanol, then methanol, because molecular weight directly proportional to van der Waals force of attraction. That's why it happens. Boiling point directly proportional to what? boiling point directly proportional to molecular weight, and molecular weight directly proportional to van der Waals force of attraction. If molecular weight are same, if molecular weight is same, that means if you are going to deal with compound which is isomerism of each other, then boiling point inversely proportional to branch. Boiling point inversely proportional to branch. Basically, you can also write like this: boiling point directly proportional to surface area. Surface area. And if a compound is in a straight line or a straight chain, it will have more surface area than branching. So that's why it happens. So please keep it in mind that if you have an alcohol like this, and if you have an alcohol, wait a minute, 1, 2, 3, 4, 5. So I have to make it 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So you can see branches there. So this will have more boiling point than this. Always remember, it's very important. Can I change the slide?
Yes, sir.
Sir,
Okay.
sir, I have a doubt.
Yes, ask me.
Sir, what if a compound has branching, but also has like high molecular weight?
Okay. Are you talking about something that is far away from each other? Like you are not talking about the situation of the isomerism, right?
Yes, sir.
So you will go for molecular weight. Like the way you said, it has a lot of branch, but at the same time it has a lot of higher molecular weight. So you will go for molecular weight. Okay.
Okay, sir. Thank you.
Okay. So branching, I already told you. Now see, simple. I'm gonna ask you a question about solubility. Solubility, where the force of attraction takes place. That means like hydrogen bonding will take place, then solubility will take place. And since you know that in alcohol hydrogen bonding will be there, OH is there, that's why hydrogen bonding is there and solubility takes place. So if I'm gonna ask you, this is your OH and this is your OH, which one will have higher solubility in water? That is understood. In water, which one will be easily soluble? Why second one? Why second one, KV and MJ?
So
Because it has
this is
smaller
very
alkyl part.
changes.
Yeah, see, both will have hydrogen bonding. Both will have hydrogen bonding. That is common factor. But at the same time, this alkyl group is a hydrophobic part. You have studied this from class 10th. Since this hydrophobic part increases, so the solubility decreases, and that's why this propanol will be more soluble than pentanol. Is that clear? Can I change the
Yes,
slide?
sir.
Okay. Now we are going for chemical reaction. Now we are going for chemical reaction. So see, what is chemical reaction? For alcohol, you can see this alcohol, and you can see this alcohol can act as nucleophile as well as electrophile. Electrophile. That depends upon the situation. So when alcohol break this bond COH, then only, wait a minute, let me start from here. Nucleophile, from nucleophile. See, whenever this OH bond breaks, then alcohol act as nucleophile, And whenever C double bond OH breaks, then act as electrophile. And there is a condition for electrophile. Only protonated alcohol do this. Only protonated alcohol do this. Protonated alcohol, that means alcohol is there, which is protonated. That means it has been already reacted with a proton. So it will be like this, ROH2 positive. And since you know that there is a positive charge on oxygen is very less stable, so it will take electron from this, and it will be basically R plus. So basically, whenever COH bond breaks, alcohol act as electrophile, and only protonated alcohol react in this manner. But when OH bond breaks, alcohol act as nucleophile. That means alcohol will donate electron, and in here, alcohol will take electron. Please do write it. Can I change the slide?
Yes, sir.
Okay. Now see, we are going for acidity of alcohol, that is totally related with the GOC, acidity. We are going to see the acidity of alcohols. And you know that when acid react with metal, what happens? Salt plus hydrogen gas forms. So basically, if I'm going to react this alcohol with a metal, what will form? It will form basically 2RONA plus H2 gas. This is basically sodium alkoxide, which is a salt. Sodium alkoxide, which is a salt. Phenol also react in the same manner. Like you can see, this is your phenol. And if you are going to react this with Na, you will be getting sodium phenoxide. ONA. H will be replaced by Na, and hydrogen gas will be released. And you can also react this with alkali. Alkali, you know, base. This is your OH, which is acidic. And if you are going to react this with NaOH, which is base, you will be getting again the salt and again water, not hydrogen gas. ONA, so sodium phenoxide plus water. So these are some proof that this alcohol and phenol is an acid, because when an acid react with metal, salt plus hydrogen gas forms. Is that clear?
Yes, sir.
Okay, can you change the slide?
Yes, sir.
Yes, sir.
Now see, acidity of alcohols. So in GOC, I had written that acidic character directly proportional to minus I, minus M, and inversely proportional to plus I or plus M. This is what I had written. And I'm going to give you a question which is very, very easy. Just let me know. This is your A, and then comes your B, and then comes your C. Which one is the most acidic? Which one is the most acidic? Very good, MJ. Any answer from any one of you? Very good. Ashrit. Very good. So everyone is right that you can see. Very good. This has from three side support, two side, and this is from one side, which is inversely proportional. You can see acidic character inversely proportional, so this will be the order. The most acidic C, B, and then comes A. The next is our esterification. Esterification we have studied first in class 10th. Esterification is when you are going to react alcohol with carboxylic acid in the presence of mineral acid, you will be getting ester plus water. But in class 12, we came to know when either alcohol or phenol react with either carboxylic acid, acyl halide, or acid anhydride with their respective reagents, then you will be getting ester that is conformed. So I'm going to show you how the ester forms. If you have first the carboxylic acid, and if you are going to react this with this is your carboxylic acid. If you are going to react this with carboxylic acid, now I'm going to take an example of an alcohol CH3, CH2, OH, and then comes your C double bond O, and then OH, and then there is CH2. So if you are going to react this, you can see H2O will be eliminated, and then you will be getting a sweet smelling substance that is ester. And this ester is used in the making perfumes and all. So this is how you will get ester. You can also get ester if you are going to react this alcohol or phenol with acyl halide. Acyl halide, you know, this is your acyl halide. So in the presence of acid, or pyridine, so you can see how the reaction will take place. It's also very simple. You just need to remove this HCl. You just need to remove this HCl, and you will be getting the same product, CH3, CH2, and then O, then C double bond O, CH. So this is how you will be getting the product. Is that clear? Yes or no?
Yes, sir.
Okay, very good. So always remember this, alcohol or phenol is going to react with either carboxylic acid, either acyl halide, or either it can react with acid anhydride. Acid anhydride. You can again do the same. Like if you are going to see this will have positive, this will have negative, and this will have positive, this will have negative. You just need to add them and you will get your answer. Okay. So either if alcohol or phenol is going to react with carboxylic acid, acyl halide, acid anhydride, you will be getting this. Can I change the slide? I'm gonna give you a question, very easy question.
Yes, sir.
Thank you. Now see, this is what you call phenol. For this, this is phenol, but I'm going to add this, and it becomes hydroxy. C double bond O. And if you are going to add CH3, C double bond O, Cl, in the presence of pyridine, then let me know the product. This has a name, which is salicylic acid. what you have written in the chat box. Kv2 oxybenzoic acid. I don't remember the common name. Is it 2-aceto benzoic acid? Aceto, that is good. Good. Okay. 2-carbon aceto. Oxy. Why it is oxy? Okay. Got it. Okay. Let's see. Any answer from any other? There is a common name for that, and we use that. It's very important. Common name of this compound. You can see aspirin. Very good. This is the answer. Very good. See, this is your alcohol. This is your carboxylic acid, and here it is an acyl halide. Sorry, acyl halide. Yes. So I told you that this alcohol will react with this acyl halide. So Cl and H will be eliminated, and this C will be directly going with this oxygen. So what you will be getting, you can see O is there, then comes C, which is doubly bonded with CH3, and here it is benzene, and this is your COOH. Or either you can write in this way. You can also change the position. COOH is here, and then comes your O, then comes your C double bond O, CH3. Both are same, and it has a very important. It is very important in our life. Its name is aspirin. It's common name. Very good. Please do write. Are you done with this?
Yes, sir.
Okay.
Yes.
Now see, we are going to study the chemical reaction in which carbon oxygen bond cleavage took place. Carbon oxygen bond. Basically, in this chapter, if you have studied carefully, this is your C and this is your O and this is your H, in which the chemical reaction are divided into two parts, in which the first one is cleavage of OH bond between O and H, and then cleavage of C and O bond. So we are going to study about the chemical reaction of carbon oxygen bond. And here the first reaction is reaction with hydrogen halides. Reaction with hydrogen halides. And this reaction we have already studied in the previous chapter. And here is a name for the reagent, that is Lucas reagent. Lucas reagent. And what is Lucas reagent? When you are going to mix concentrated HCl with ZnCl, this is called Lucas reagent. Okay. Now see what we conclude from this reaction. If you have a primary alcohol, if you have a secondary alcohol, if you have a tertiary alcohol, and you are going to add Lucas reagent in this, you will be seeing that there is no reaction here, and the reaction will be completed at room temperature. I will show you the reaction. I will tell you the reason why it happens, and we can say no turbidity. No turbidity. Then comes your turbidity is there after 2 to 3 minutes. Turbidity will be there. That means product will be there, and here immediately turbidity takes place. What does this turbidity means? Basically, in the preparation of alkyl halide in previous chapter from alcohol, if you have seen, we used concentrated HCl in the presence of ZnCl2. And this is known as Lucas reagent. And if you are going to react this, there will be formation of carbocation. Carbocation. And as you can see, this is 1 degree. So here it will be 1 degree carbocation, which is unstable. That's why at room temperature, the product will not take place, or the reaction will not move forward. But for 2 degree, it is slightly more stable than 1 degree. So the product will start formation, and after 2 to 3 minutes, the product will start appears, and it is basically turbidity. Here we should write turbidity. Basically, the solution is cloudy. That's why it is. We are talking about turbidity, and tertiary is very very stable. That's why immediately after the reaction, you will see turbidity. That means product will start appearing soon after reaction. Is that clear? And this reaction we also do to distinguish between primary, secondary, and tertiary alcohol. If you have got 3 alcohol or mixture of alcohol, you can do this experiment to classify them as primary, secondary, and tertiary. Is that clear? Please do let me know.
Yes, sir.
Yes, sir.
Now the next one is, you already know this, reaction with phosphorus trihalide, PCl, PX3. And you have seen this reaction. If you are going to react this ROH with the PCl3, just tell me the product. You will be getting RCl along with phosphorus acid. So this reaction you have already studied. The next, which is important, that is dehydration. And it's also very important, easy. Dehydration, that means a removal of water molecule. I'm going to give you directly question and let me know. A removal of H2. So just let me know the product. First, you are going to treat this with H2SO4, 443 Cal. Then name of the product you are going to send it to me. Name of the product. Very good, MJ. The reaction is quite easy. Only I'm here to clear your concept so that every questions you will be able to solve. You need to focus on the basic first. Protein, very good. Adriel, any answer? KB, PD. Okay. Adriel, you should write the name instead of writing the family name like alkene. What is the name of the compound? Ethene. In every of this reaction, in all these 3 reactions, you will be getting alkene, because you can see this will be your ethene. What you need to do, remove OH and remove one hydrogen from another carbon. Remove OH and remove hydrogen from here or here, you will get the same thing. Remove OH and remove hydrogen from here, wherever you want, you will be getting the same product like this. Okay. What I want to show you is that, very good, that this dehydration reactions mechanism proceed through the formation of carbocation. What? Carbocation. Very good. Carbocation. So you know that here 1 degree carbocation formation takes place. That's why concentrated H2SO4 and 443 Kelvin high temperature is required. But after 2 degree alcohol, there will be 2-degree carbocation, which is slightly more stable than the primary. So we don't need that much dehydrating reagent and temperature. And for 3-degree, you can see 20% S3PO4 and 358 Kelvin. So all I want to say is that this dehydration is proceeds through carbocation. Okay, and we can easily decide our product. I'm going to give you a question. These are some easy questions that either you are going to remove hydrogen from left carbon, right carbon, above carbon, or below carbon. You will be getting the same product. Okay, so I'm going to give you a question. Are you done with this? Can I change the slide? Okay.
Yes, sir.
H2SO4 is a dehydrating reagent. You have to why the answer is not but one in. You just remove OH from here and H you can remove from here and H you can remove from here. But that is a very good, that is correct answer basically. But2 in will be the but2 in will be the product. PD, you have written the formula wrong, I think. CH2, CH3, CH2 not CH2, it will be CH. So this will be your but2. Okay. Is that clear? Your this will there will be two product. There will be two product, and this will be your but1 in, and this will be your but2 in, which will be major, and this will be minor. Can I change the slide?
Yes, sir.
Very good. Now see, we are going for the next reaction, that is oxidation. And oxidation, that is dehydrogenation. That means, wait a minute. Oxidation, we are going for oxidation now. And oxidation, removal of hydrogen. And in organic chemistry, we call it dehydrogenation. Dehydrogenation. That means removal of hydrogen. And how we are going to remove hydrogen, it's very important. You have to be careful while removing hydrogen. It is fixed that you are going to remove one hydrogen from one hydrogen, this one hydrogen. That means the hydrogen which is connected with oxygen, and another hydrogen you are going to remove from this carbon, the carbon which is connected with OH. So if you are going to remove this and this hydrogen, you will be getting, if you are going to use an oxidizing agent to remove this, you will be getting this carbonyl compound. Either you will get aldehyde, either you will get ketone, either you will get carboxylic acid, depending upon the oxidizing agent that you are using. But be careful while you are, this is your, while you are going to oxidize tertiary, 3-degree alcohol cannot be oxidized, can't be oxidized. As you can see, there is 3-degree for 3-degree alcohol, there will be no hydrogen with this carbon. Hydrogen is absent. Hydrogen, no hydrogen. So if the no hydrogen at this carbon, so this will not be oxidized. Always remember that. Okay. Can you change the slide?
Yes, sir.
Okay. So if you are going to oxidize this, this is 1 degree alcohol, and if you are going to oxidize with a strong oxidizing agent like K2Cr2O7, or you can use KMnO4, or either you can use CrO3 plus H2O. Basically, this is your Cr H2Cr O4. Then this primary alcohol will be directly converted into carboxylic acid. Is that clear? And if you are going to use mild oxidizing agent like PCC, pyridinium dichlorochromate, then this will be converted into LD. Is that clear? So it's very simple. And if you are going to use this CH3CHOH, PCC, so you can see in oxidation what I told you to remove hydrogen, you are going to remove this hydrogen and this hydrogen, you will be getting CH3 C double bond OCH. Got the ketone. This is your ketone. You also did the same with this. You just remove OH from here. Not OH. We are doing oxidation. So you are going to remove hydrogen from here and one hydrogen from here. So what you have left CHO. So this is what you will get. Got it?
Yes, sir.
Can I change the slide?
Yes,
Okay.
sir.
Yes.
So everyone, I'm gonna ask you, are you comfortable with the preparation of phenol? Can you do it by your own preparation of phenol? Yes or no?
Yes, sir.
Actually, since we have very less time left, and since you just passed class 12th, you have studied all this chapter. If you have any doubt in a particular topic or in a whole chapter, I'm here to teach you. Okay, but if you already know these things, basic things, then if you are comfortable with all these basic things, then directly I will go with the question or the concept. Are you getting my point, Marita, Adriel, Krishna, KV?
Yes, sir.
Everyone knows the basic concepts, right? So that is what I'm going to apply from tomorrow's class. I will be asking with each topic according to NCRT, like preparation, chemical reaction, physical properties or chemical properties. I'm gonna set a question according to NCRT books, and you are going to directly solve it rather than I'm telling you all these things that you already know. I think, I hope so. You can directly practice that question, and then we will directly jump to the PYQs of JEE. Okay. So this is your preparation of benzene. So can we, okay, I'm gonna do this for you. Preparation of phenol. So first of all, we are going to do it from chlorobenzene or haloarenes, from haloarenes. So if we are going to do from haloarenes, you know that this is your chlorobenzene. And what you need to do, electrophilic substitution reaction. No. So this is Dow's process. If you remember, 623 Kelvin and 300 atm pressure, then you will be getting a phenoxide ion, O negative and a positive. And after this, you are going to do the acidification, and you will be getting phenol. So this is how we get phenol from haloarenes that we already studied in the previous chapter. Wait a minute, please. There is someone. Okay. So am I audible? Marita, Adriel, Krishna.
Yes, sir.
Yes, sir.
So this is the first preparation, and this is also known as Dow's process. Dow's process. Okay, I'm gonna ask some question. Please hold on a minute. Can you do this, please? Please do this. What is the name of this compound? Marita, Adriel, KV, and Rian. Very good. You mean. So if we are going to react this with O2, that means if you are going to oxidize it, what you will be getting? You will be getting cumene hydroperoxide. Cumene hydroperoxide, and this is what you will get. CHOO. Wait a minute. This will be like this. And this CH3, I'm going to write it on top, and this CH3 on the left. So this is your cumene hydroperoxide. And after doing hydrolysis in the presence of acid, what will happen? This part will be eliminated in the form of propanone, CH3, C double bond O, CH3, and you can see this is what you will get. Is that clear? Marita?
Yes, sir.
Okay. Very good. Can I change the slide?
Yes, sir.
Okay. Now you are going to arrange this in decreasing or increasing of order of boiling point. Pentane 1 all, butane 1 all, butane 2 all, ethanol, propane 1 all, and methanol. So please do this question, and today I will be over the class here. It's iftar time, so that's why. Just tell me which one will have the highest boiling point. We are talking about boiling point. Which one will have the highest boiling point? Very good. Who said? Okay, Krishna. Very good, TD. And the lowest one will have the of the methanol, right? Very good, MJ. Very good, very good. I'm gonna give you another question. Just wait a minute. Just let me know. It's a very simple question. It's not any tough and all. Just let me know the name of the product. And I'm gonna recommend you, all of you, to please read this ether and carbonyl chapter for tomorrow class, because I'm going to not cover the theoretical part like this. I'm gonna cover the question part. Okay, so please be prepared for that. Butane. No, it's wrong. Butane 2 all is will it be? See what will happen. This is your what? This is your aldehyde NABH4 is a reducing agent. Very good. So what will happen? CH3, CH2, and this CH3, CH, and then this CH3. Then this CH2, where CHO will be converted into alcohol. And it will be 1, 2, 3, 4. 2-methyl butanol. Very good. So this is it for today. Guys, I'll see you tomorrow. And please, you have notes of carbonyl as well as ethers. Please do read about that, and then I'll see you at tomorrow at 5 p.m. Okay. We will do the PYQs and important topics and